Hello. It's already Friday night or Saturday morning in Japan time. I'm gonna start the live stream for today. Okay, so hello. Hello everybody. This is Junichiro Horikawa and this is the Houdini Algorithmic live tutorial live stream for Houdini, and this is 127th episode. The topic for today is to create a procedural weaving vessel-like model like these. Yeah, from scratch, based on a mirrored, repeated voronoi pattern on several layers. Make a weaving like these using bunch of Houdini nodes and Vex. Okay, so that's what I'm gonna try to do. Since this is parametric, you can change a bunch of parameters to have different shapes. You can also change the profile of the vessels by changing the curve, cross section, like the one you see right now. Which is, well, I'll show you that later. So you can select it, move it, and this will change the final geometry. Okay, so this is what I'm gonna do, and since the logic itself is pretty easy, I think it's nothing difficult for today. So the process that I'm gonna do today is to first set up some profile curve for a cross sections in order to create a vessel like shape using revolve. And I'm gonna create bunch of profiles by creating wavy shape based on the input geometry, input curve. And for each weaved or wavy curve, I'm going to create a different profile and different revolved geometry. Then I'm going to create a repeated voronoi pattern for each layers, for each geometry or surface, and going to create a skeleton out of the voronoi shape, making a skeleton shape like these. And as you can see, if you look from specific directions, the geometry is mirrored. So I'm going to create this kind of pattern using voronoi as a base. If you just use voronoi as it is, it's just going to be pretty random, but if you control the point position for the voronoi, then you could kind of get these kind of repeated pattern. And if you do this for all the layers, all the surfaces, I'm gonna get kind of a repeated clean pattern or geometries like these. And you could also control how many repetitions you want for the voronoi. This is the minimum repetitions just on the left and right, but if you increase the repetitions, you see the similar patterns on many angles like these. So that's what I'm gonna try to do. Alright. Okay, so shall we start then? So today I'm going to start by creating a geometry as always. Then start by creating a cross-section curve in order to make it as a base for the vessel. Okay, so let's change the view to a from view to create a curve. Okay, now I'm going to use, let's say, curve polygon. Hello everybody, thanks for joining. And just draw as you like. Yeah, something like these. And let me tweak this a little bit. Doesn't really matter how it looks like. Okay, let's say I'm gonna go with these. Then right now it's a bit too blocky, so I'm gonna smooth this out by using the resample node to add a bunch of points, and at the same time smoothen out by making this subdivide curve or interpolated curve. Either one is fine. I think I like the subdivision curve. Okay, so let's connect this to a new node. Call this curve as an input. Okay, now I'm also going to make a group, apply a group to this curve. Just gonna call this curve. Right, now first thing I like to I'm gonna do is to create a revolved geometry from this curve and try to create a repeated voronoi pattern on top of those, on top of this surface. Then later on I'm going to create another layers doing the similar same things, probably using for each loop. Okay, so start by creating a revolve. This will create revolve geometry. Let's look at this from the perspective view. Right. Now and let's what to do next. Now I am going to try to create a voronoi pattern. Well, let's also make this a little bit high res by making the resolutions a bit high. Okay, so the next thing I would like to do is to create a voronoi pattern on top of this surface, but I want to make a repeated voronoi pattern on this soft surface, meaning the pattern should be mirrored on specific direction or specific view. For example, in this view, I want if this is the center line, then I want to have the left side and the right side to have the same pattern, so that it will look like a continuous, a clean pattern or symmetrical pattern. Okay, in order to do that, you just need to place the points on a mirrored positions. For example, if you have a surface on this side and surface on this side, and if you place those points on the left side like these, then the voronoi look like that. Now placing the same point, those points in a mirrored position on the right side, this will create an exact mirrored shape like these. Doesn't look mirrored. Okay. Since the point is pretty much in the same position. Okay, so using this concept, I'm going to define how many like splits I want to have for this revolved geometry and make these mirrored shape as much as I want. So let's start by defining how many split I want, and I think it has to be a multiplication of 2. So the minimum will be left and right repeated, and the next split will be 4, and the next split will be 6. So one pair of 2 surfaces will be acted as one surface. So it's by dividing this surface with the multiplication of 2, you should be able to create a repeated pattern using mirrored point position. So let's try to create. Hello everybody. I have a side note question. Want to learn a game engine software? Which one you would recommend out of Unity or Unreal? If you have any advice for me, it will be much appreciated. I'm using Unity myself a lot because that's the game engine I started using, but I also use Unreal time to time because it's also easy to use. I mean, and outcoming graphic is stunning without much setup compared to Unity. So either one is great. If you are more into text coding, maybe Unity could be the starting point, or if you are into the mobile development, like making iPhone app or Android, so on, WebGL, maybe you can use Unity because there are a lot of resources for that. If you're into more standalone like app or game using high quality graphics, then maybe Unreal might be better because it has a lot of resources for that. So it's up to the objective, I guess. So where was I? So what I wanted to do is to split this surface based on how many mirrored shape I want to have. So let's create a controller having a parameter. Let's name this, how did I say, mirror voronoi mirror number. I learned a lot of all of X from this. Thanks for saying that. Okay, so let's say 1 is the minimum, 10 is the maximum. Okay, then copy this value to create a mirrored shape. So if it's 1, I'm gonna multiply by 2, meaning as a output you're going to split the surface into two. So let's create a for loop to create a looped a mirrored shape. I'm going to use a for each number here. Probably I'm going to do the loop for the curve and do the revolved inside maybe. Okay, now I'm going to copy this value here, paste it to the iteration here, multiply by 2 so that I'll have two surfaces. I can create two surfaces in here. Right. Now, first thing I'm going to do is to create a revolved surface from this curve inside here with a amount of angle which is divided by this the whole loop number. So in this case, the revolved geometry has 360 degrees as a total. So if you divide it by 2, one surface has 180 degrees. So revolve. Let's have this here and control this value here by copying this value, or you can copy this value. Maybe I'll just copy this value since it's already multiplied by 2, and then divide 360 degrees by this number, which will create 180 degrees. Now it's not yet, doesn't look at 180 degrees. Oh, because I need to make it this open arc. Yeah. Okay. Next, I am going to plot some random points on top of this. Then for the next loop, I'm going to place those points at as a mirrored value on the other side. Now that I think of, maybe I can just do this outside for the base surface and the points, then just move the points inside this loop. Yeah, that will be much efficient. So first I'm going to create a base surface outside the loop, like this. Then create a scattered point on top of the surface. Now let's try this with a small number of points for test, like 20 or so, or 25 or something. And if you want to have more randomized positions for the points, you can also turn this off or make this value small. Okay, it's up to you. I'm gonna make this to 1, just a little bit of relaxation. Okay. Now next I am going to go inside the loop, and what I want to do is to mirror these points on the other side. And because if I change this value, the angle will change, and if I make this to 2, you're going to have 4 surfaces. So this points should be mirrored this side. This also points mirrored on this side as well. And the mirrored points somewhere on here should be again mirrored on here. So if you think about it, you can iteratively think that points will be mirrored in a clockwise direction. First, these things will be mirrored here, rotating clockwise. Then in the next iteration, this could be mirrored right here. rotating clockwise, and this one mirrored right here, rotating clockwise. So, and the total number of loop in this case is 4, so it makes sense. So if I make this to 1, this will be rotated clockwise and mirrored right here, so it makes sense. So as a test, probably using number like 2 or 3 might be better for a test or general usage. So I'm gonna go with 2, meaning I'm going to have 4 surfaces. Okay, and if this works, then it should also work with the value 1. Alright. So what I want to do is to move or mirror this point positions based on the surface positions one by one. So in this case, I think it makes sense to use a feedback each iteration, or maybe not this one. I'm gonna make this merge iterations, but for the input, I'm going to use a fetch feedback so that you can use the last updated point position as the next input. Yeah. Yeah. Then I'm gonna use vex. Probably it's also possible to do with the transform node, but you kind of need to refer to the iterations or change of axis, so it's a lot of expression to write on transform node, so I'm just gonna use vex for that. So let's do this. Gonna name this mirror. Now in order to create the mirrored shape or mirrored point position for those points, you need to have a mirror plane. In this case, for this point, if I want to rotate clockwise, then I need to have this x, y plane information. Now, I think there is a function for vex in order to calculate the mirrored position, I think. So let me check. Is it mirror? No, it's called reflect. Yeah, so we can use this function from a vex in order to calculate the mirrored point position based on this 2 inputs. The first one, it says direction, but it could also be position, so consider I'm going to place position in here, and the normal is the normal for the mirrored plane. So if the plane is xy plane, then the normal is z direction. Alright, so 2 information I need: position, which I already have it, and the plane, normal. Now for the normal, for each loop I need to rotate this 90 degrees in this case, if the iteration is 4, and I also need to have the normal direction for the plane as initial values. So let's create that outside the loop first. Shall we? And for this one, I want to check which direction could be the first normal direction. So you can see that this plane is being fixed here. So I can guess that this direction, in this case z direction, could be the initial reflecting normal or mirrored plane z direction. So I'm just going to use attribute create, call create a axis vector value for each point with the value 0, 0, 1. Now, if you check the geometry spreadsheet, you're going to get this axis vector value, vector attribute on each point. And now I'm going to use this to calculate the mirrored positions for each point. Alright, now going back to the mirror. Let's reset this to 2. Let's try to calculate the mirrored positions for this point by using the reflect function. Now the first input is the point position. The second input is the axis. And let's see what happens if I update the current point position with the reflected position. Oop, just disappeared. I'm gonna write this again. Reflected position. Direction should be normalized or not. I think it should be normalized. Otherwise, the reflected point position could be skewed. I'll check that. Okay, let's update the point position. Okay, so checking from the top view. Yeah, I think it is being mirrored. Yeah, so this is the original point, this is the mirrored point position. Okay, and let's check if I change the scale of this normal. Let's see what happens. Yeah, it just skewed. So seems like the normal value here has to be normalized. So this might be safer. Writing like this. Okay. Now this is one loop, but in the next loop I need to change this axis to, since then in the next loop I want to mirror this shape using this plane here, and this plane's normal direction is in this case x direction, and you can get that by rotating the z axis, the original axis, by 90 degrees clockwise in this case probably. So you kind of need to update this v axis. So let's do that by creating a rotational matrix, starting by create identity matrix, creating a rotational matrix by rotating. I mean, you can not just say 90 degrees because it's up to a division number here. So, and in order to get the right angle, you need to divide 360 degrees by this number of iterations. So let's copy this again and have that value here. Or you could get that value from the meta node here, which you can get it from the detail attribute. Detail. One's called num iterations. This is the attribute, the detail attribute coming from here, which shows the total number of iterations. Yeah, well, total number of loops. Alright, so now I can have this. I can calculate the angle by dividing 360 degrees in other way, pi multiplied by 2 in radians divided by the number. And you can use this angle to create the rotational matrix, and you can use y as a rotational axis. And now finally you can rotate the axis attribute by this matrix. Now hopefully this is rotating the right direction. If not, I might need to make this angle negative. As a result, yeah, it looks like it worked. Let's try to change the split, and if you see some repetitive pattern on here, on some specific divisions, like these pattern and these pattern looks the same and so on, all things are repeated, then I think this is fine. Okay, looks good. Now let's try to use this point to create the voronoi pattern and see if it's symmetrical or repeated pattern. Alright, so create another revolve shape. This time a 360 degrees full revolved shape with enough divisions. See what happens with voronoi using these repeated points. And I should avoid creating the interior surface, just want to need the outer surface, hide the UV, and it's a bit hard to see, so let's change the color based on the or based on the area probably. So let's see, I'm going to output the parameters for each primitive, which piece belongs to which mesh belongs to which piece. So I can either use name piece or cell PT. Okay, now I'm gonna calculate the measure. I'm going to calculate the area using measure node, and per piece using, let's use piece. Then based on the color, based on this area, let's try to color it. Primitive, random from attribute, and use area. Okay, nothing happens. Let's see. So am I calculating the area? Yeah, I guess I cannot use randomness with the float value. Might need to be integer value. Probably. Alright. So I'm just gonna multiply the area by 1000. Alright. So as you can see, I think it is being mirrored correctly. Well, I do see some weird stuff here, but overall looks fine. Let's try out with different divisions. So this is left and right mirror shape. Looks okay. Okay, so overall looks fine. Now I do see some weird stuff here, so let's see what's happening. So let's see. So seems like there's some duplicated points on somewhere around here, or not duplicate, but really close in a really close distance. So in those cases, I might just need 1 point. So let's optimize this a little bit. Going back to this mirrored shape together with, or going back to the original surface here. And also check the points on top of the surface. Now, I could say that if the point is really close to the border, then just stick it to the border. We'll delete the points on the border, either way. Because if it's too close to the border, then there's a chance that another point is going to be placed really close to each other. And this will create as a really like split on a center. So I want to avoid that. So in order to avoid that, I'm going to place this. If the point is close enough to the border, I'm just gonna stick it to the border. So how do I do that? In order to do that, I need the outline of the surface, I guess. So I'm going to first of all delete the inner edge by using divide node with this remove shared edges, then use polypath to get the outline like that. Then calculate the distance between these points and this outline, and if the distance is close enough, then just stick it to the boundary. Okay, so I'm gonna do that. I'm gonna do that using Vex again. Okay, so first let's calculate the minimum distance to the curve. You can do that by using XYZ distance. Then as an output, you can get the primitive number and the UV. Now check the distance with some threshold of your choice. And if the distance is small enough, then place the point on a minimum position using premuv like that. Okay, now let's see. Let's check. Having the parameter t as a threshold, if I increase this, so if this will be the distance to check if the point is close enough to the border. If it's really close, then just stick it to the border like that. So this could be a parameter which you might want to control later, so let's have that here as a global parameter so that you can later on control it by yourself. Alright, now going back to the final output here, I can then use the fuse node. So if the point is at the duplicated point position, then it will be trimmed to single point. So previously it was 364 points. After the fuse, it's the same. It's the same. No, it's after the trimming, it's 308 points. Okay, so as for final result, yeah, you're going to get a better result. Alright, let's check. So overall, looks fine. At some point you get this mirrored shape in any number, in your repetitive numbers. Yeah. Alright, so next I am going to create a bunch of similar layers like these and make it waved so that it will create an interlaced shape for weaving effect for ladder usage. So basically I'm going to do the similar things that I did here for specific number of loops. If you want to have 4 layers, then you're going to use 4 loops to do the same thing, but with different profile. Changing the curve profile with the wave. Okay, so that's what I'm gonna do. So let's do that. So I'm going to create another loop here for each number. And let's have the parameter to decide how many layers you want to have. Starting with 1, maybe maximum 10. Let's try with 3. Copy this and paste it here. For this one, it doesn't have to be feedback loop, so I'm going to stick with a merge each iteration and the fetch input. Now for the fetch input, what I want to change is the profile first. So I'm going to connect this curve here. Now, what I would like to do is to create a wavy curve and probably using a trigonometry like sine wave and change the frequency or shift the frequency so that you'll get an interlaced surface for each layers. So first, in order to do that, first you need to have the total number of how many numbers of layers you have so that you can calculate the frequency and how much you should shift it. So let's try that using point wrangle. And in order to create the wavy curve out of this input curve, you need to know in which direction you want to move those points, the points on a curve, to create a wavy curve. So what you need to have is the tangent vector and the normal. And you can get that by orientation along curve. Or if you just need a tangent, you can go back to the resample node and just turn on this tangent U. And you can calculate the normal direction by rotating this tangent vector by 90 degrees using the axis. Okay, so let's do that way. Let's check the tangent u vector value. With the vector marker. Okay, so currently the tangent vector looks like this. So I want to rotate this vector value 90 degrees along the z-axis as an axis so that you can have the direction in which direction you want to move the point to. So let's do that by, first of all, copy the tangent u to a variable, create the rotational matrix like I did previously, rotate the matrix by 90 degrees using z axis, then rotate the direction with this matrix. Let's check it by applying this direction to the normal. See how it looks like. Okay, so looks correct, looks fine. Might want to have more points to have more high res wave value. So I'm going to make this resample curve length to 0.05. Yeah, it's not really necessary, but just to make a bit more high res. Okay, so this will be the direction that I want to move along with the sine wave. So let's use next, let's create the sine wave. Wavy curve. Okay, so in order to create the wave or sine wave, you need to define the number of frequencies, amplitude, and how much it's been shifted from the starting point. So let's do that all here. First of all, frequency, it could be a multiplication of 2 pi. 2 pi is one wave, one continuous wave. So I'm going to multiply some value to this 2 pi. Which could be a wave number, which can be called as a wave number, but it doesn't have to be integer. I'm just gonna call this wave num, but could be float. So let's increase the range from 0 to 10. Alright. Now let's create the sine wave using sine function. This could be actually called as an angle. Right. Then you're going to have a up and down value going from +1 to -1 repeatedly with this number. If you set the wave number to 2, you're going to have 2 waves going up and down 2 times. Okay, now let's try to use this value to move these points to this direction. So to do that, you kind of need to apply the point position or point information, each point information, to this angle. in order to get the wavy height, wavy values based on the position. So going back to the resample node, let's also output curve U. This will output a value from 0 to 1 from starting point to the end point. And we can use that value to apply a specific angle for each point. So the final angle could be the total number of angle multiplied by curve U, so that the value will be in between 0 to this maximum value. Okay. Now let's try to move the point to the direction multiplied by sine value. Now the moving direction, the amplitude of the wave is a bit too high right now, so let's also calculate or set the amplitude for this wave. Okay. So currently there's only 2 waves, so it's a bit hard to see if there's any wave being applied. So if I increase this number here, wave number here, you can start to see wave is happening. Wave is being generated. Okay, that's good. Now that's for the single layers, and for the other layers I want to move the same frequency wave and shift it to this direction to by changing the angle or adding some shift angle to each sine wave for each layers. For each layers, change the shift value for the angle. That's what I would like to do. So in order to do that, you need to have this iteration number from the detail. In each loop you get different value as an iteration. If you look at the detail, this is the number which changes in each loop, starting from 0, goes 1, 2, 3, and so on. So we can use that value to create a shift angle. So let's get that value first from a detail. Detail, duration, 0. Okay, and now we can calculate the shift angle by multiplying the iterations by some angle value, but this angle value could be related to this total number of frequencies actually. So shall we do that? So actually, if you are having in total 3 loops, then shifting it by 120 degrees might be good. So the first wave have a 0 shift, in the second wave you're going to shift one by 120 degrees, and the third wave you can shift it by 240 degrees. Then all the wave is positioned in a different location. Everything has different height or a different wave, and it'll make more sense to use it for interlacing later. So let's try that by multiplying iteration by pi multiplied by 2. This is 360 degrees divided by the total number of iteration. In this case, you can also get that from the detail. just like we did last time. Like this. And add this here. Now if you go outside the loop, now you get this kind of a DNA like wave pattern. And if you, even if you change the number of loops here, number of layers here, you're always going to get an interlaced result. Alright. Let's try with 3 for now. And this is the surface, this is the profile curve that I want to use for each Voronoi surface here. Okay. So, and let's go with smaller number of wave number. Now I could promote these parameters again to here, so let's do that. Gonna drag and drop this value here and this value here. How do I name this? Curve wave number. Curve amplitude. Curve wave amplitude. Hello Castle. I have a question about curves. What is the best way to offset curves in Vex, especially on a sharp corner pieces where overlaps might happen? Well, it's a good question because it's pretty hard to offset a curve, especially in a really sharp wave. Well, one of the easiest way is to use a node from a side effects labs. I think there was a specific node for that. What was it called? Like no. Didn't have it. One of the way I would do it the easy way, but you're using MVex. Okay, so MVex, if you have a sharp corner, kind of a need to yeah, where overlaps might happen. Yeah, that's pretty hard. It's pretty hard. I don't think it's that simple to solve the overlapping problem for the offset just by using Vex, because it's going to change the number of points for sure. You kind of need to calculate the boolean curve boolean, delete the intersected point, delete intersected or self-intersected curves. So if you want to do this all in Vex, it's gonna be tons of coding, I think. From what I could imagine. I mean, I did try that some time ago, but it didn't really work out. So what I used is poly expand for that purpose. Or you could kind of loosely offset the curve by not deleting the point within the Vex, but later on you can delete it by using a combination with the intersection stitch or intersection analysis to search for the self-intersected curve and delete that part. Now that's a lot of work to do, but that might also work. So, just have to say, no simple solution. There might be, but I couldn't figure it out. Okay, what was I? So I think I have placed the parameter here. So it's time to merge these loops together with these. So what I want to do is to use the profile curve that I made here to create a base surface for the voronoi. So let's connect this right here. And then we also need to connect this curve to here as well. Okay. Now we can go outside the loop by connecting it here. See what happens. Okay. Let's recalculate the normal. Let's also add some alpha channel so we can see through. Alpha to 0.4. Actually, it didn't really show. But as you can see the interlaced surface like these. Okay. Alright, so now that I have this profile surface, what I'm gonna do next is to get the outline curve for each voronoi and then try to create a weaving pattern out of these. Okay. So let's do that. And where shall we do that? We could do this outside the loop or inside the loop in order to get the curve. Which way is better? It's fail-safe to just do it inside the loop, but it's gonna be slower. It might not be good to do this outside the loop because there's a chance that some of the point is touching to each other for different layers. So let's just do this inside the loop. Recalculate the normal here. What's this? Okay. Funny outlook. Let's reduce the amplitude a little bit. I think it's being offsetted too much. Yeah, somewhere around here. Okay. Okay, now let's see. First, going to try using divide node. Remove the shared edges. And check how it looks like. Okay, so I want to make it really simple as possible, so I want to delete these inner points so that it will be a straight line for each voronoi shape, voronoi cell. Okay. I mean, we could keep these points as it is, but in order to make the consistent smoothness later, I think it's better to make it straight from what I have tried out earlier. So I'm gonna remove the inner points. In order to do that, first I'm going to fuse the point. Then there is a I don't know if I can use this, but let's try. I could try using facet node with a remove inline points. Although this doesn't really, this is based on the angle. So if I just want to delete every points on each edge, this does not work. So let's just do this in Vex way again. So in order to do that, you need to find the rules, which point you want to delete. So if you look at those points on the edge, you see that the neighbor point always is equal to 2. You always have 2 neighbor points for those points on the edge. If it's on the corner, then you have at least 3 points and the neighbors. So that could be the conditions, which points to delete. So if neighbor count of the current point number is equal to 2, then delete that point. There you go. Now, is this okay here? Yeah, seems okay. So everything becomes straight. The line becomes straight. This is to simplify the later process. Okay. Now that's good. Next, I'm going to, since the final result is the weaving pattern, I'm going to convert this into a bunch of lines by using convert line. There you go. All right. Now, after this, I want to make it, I want to make it smooth. So let's add a bunch of points to the final result, to this final result, by using resample to add additional points to each edge by a specific number of, or specific length. I'm just gonna go with 0.1 as a default value, might change later. Okay, now, and as a final step, I would like to fit these points to the original surface, which is this one, to make the curve smooth again. Okay, so I'm gonna do that, and I am wondering if I should use a minimum distance or a some other functions to fit these points to the surface. I mean, minimum distance might not work in any situations, in some situations. So I want to use a more fail-safe way to project these points to the surface. So how would I do that? Let's go back to here. Maybe we can use some UV value. Okay, so for now, at this point, this is still stick to the original surface somehow. So, and after removing all the points, it will just we'll just lose all the informations. So, and I'm re-adding the points here. So it's a bit tricky. Yeah, it's a bit tricky. But maybe I should be able to do this. Okay, so going back to this revolved surface, let's create the UV for this one. This is the first time I try this, so I'm not sure if it's gonna work or not. So let's create a UV using UV flatten or something. Should work because this is just a revolved shape. Not good. Let's just use more simple UV. Wait a minute, it already has UV? Where does it come from? It already has UV. Maybe this is already creating the UV, so that's good. So I can just use this. This is vertex UV, yeah. So I can use this vertex UV to map this curve to the original surface. Okay, so in order to do that, first thing I'm going to do is to let's see. What will be the best way to do that? Gonna have to know that each line, each point positions used to be here belongs to these curve. So I need to have some kind of a link between these points with these lines. Now, what could be the best way to do that? Let's see. What will be the best way? Maybe I could just convert this part with lines. This will create a bunch of lines for each edge. Yeah. And what I want to do is to merge these lines with as one polyline. So how do we do that? The condition is that there's a connection on the corner where you have three neighbors. So it's not that straightforward to do, is it? Let me think. If you have any ideas, let me know as well. So if I have these curve and if I have these points, how do I relate to each other? Okay, I have some ideas. Okay, so currently this is all connected because this is fused, but I can make the connected points, the corner points, as a disconnected points by referring to this geometry, which only has the corner points. So go here. Look for the nearest point. Trying to calculate the distance. Distance between the current point position and the nearest point position. And if the distance is small enough, meaning if the point is at the corner, then you could set the group to disconnect. Now I could use the unique point node to disconnect the point which only has this disconnect group. Now if I double click the edges, it's now being selected only on the each edges. That's good. Now I can use polypath to connect all those lines into one connected polyline. There you go. Okay, now I could get the UV value for each point on this curve, or just resample this curve. Like that. Maybe that's all I needed. Maybe I didn't really need UV. So this part is not necessary anymore. Yeah, maybe this is just fine. This will just do the job. Yep. So just get rid of these. I think this is more nice solution. Undestructible solution. Okay. Connect it here. Let's see the final result. Now the interlaced surface becomes an interlaced curve. Now, thing that I noticed is that there are curves which are on the same line like these, which I don't really like it. Let's see. Why is it happening? Is because I'm mirroring in a same angle, so maybe I also need to shift the rotation for this mirrored stuff in order to avoid having the same line appearing on the same position. I mean, it's up to you. It's might also be fine to have it, but might also be good to have the option to shift the angle as well. But let's see if I really need it or not. So this is for the one curve. As you can see, I have a bunch of edges on a mirrored plane, which can be controlled by increasing the border threshold. If you increase it, this will change how mirrored shape works. So it's up to controlling this one. Also changing the number of points as well. Do I have a number of points as a parameter? No. Let's have that as well. Let's have these point number. Applied as a parameter. Maximum, I don't know, 200. Okay. So let's see how it changes. Interesting. You could also go back to the scatter node, change like without the relax. This will also change how it looks like in terms of the how the voronoi layout works. So you can also change the global seed. Probably the global seed has to be changed for each iterations to have different point position on each loop. So let's apply that. I'm gonna refer the detail iteration value from this node, and applied it to this global seed. So detail for each count 2. And multiplied by some value. So this, hopefully this will change upon point position for each loop. Will make a bit more randomized interlaced curves. Well, not so much on these edges, so another things that I could do is to shift the angle for this mirror, say for each loop. But as a result, the symmetry might be broken, so I'll just go with these shape for now and come back here later if things got not so good. So far I think this is fine. Let's also add some seed value to the parameter so that you can change the randomness, or you can pick some random value, different random values. And mostly it could be used for the global seed for the point. I guess that's probably it. Right. Now it still is a curve, so I want to make it as a a pipe shape, but before doing that I need to make sure that nothing intersect by themselves. I need to resolve the self intersections to make it look like it's interweaved. Okay, so to do that, what I am going to do is to use a detangle node from Houdini, which will use some I don't know, force-based functions inside to repel the points with specific thickness. So you can specify the thickness to update the point position so that the curve won't intersect each other. So that's what I would like to try out. So let's do this, shall we? Now before doing that, I want to check number of points that I have here, and I want to also make it smoother. Currently it's a bit too voronoi-ish, too hard. So in order to make it smooth, I'm going to use a smooth node for this. So smooth node. Now just make it, just briefly smooth it out. I might need to actually I might need to fuse it because every edge is being separated. So let's fuse it, and that will smoothen out the surface a little bit, like that, like a bubble-like shape. Yeah, I'm gonna smooth it with a really high value, like 50. Okay. Now let's use this to let's use this together with this detangle node to avoid the self-intersection. So in order to use that, in order to use the detangle node, what I need to do is to first create the rest position for each point. Rest position is like an original point position, right? Then I'm going to create a for each loop. I'm going to create a feedback loop. So just applying this detangle node once is not good enough. If you try to do this, original point position to 1, you see that it's a bit too wiggling too much. So I want to make it a bit more smoother in terms of these curve point movement. So what I want to do is to make the thickness really low and continuously doing this over and over again to gradually change the point position, which will hopefully make the curve a bit more smoother by just rather than applying this one time. As you can see, if you make it this value too big, you create really jaggy curve, that which I don't really want to have. So connect this here, make it really small, and I want to make it feedback loop, feedback, fetch, feedback. Okay, and try to make this small enough. Now this also might need to be parameterized based on how much thickness you want to have as a final result. So let's create another parameter in order to define the thickness. Thickness. Let's say it's from 0 to, I don't know, 1, or will be the appropriate value for this. Not sure yet. Okay, now let's try to use this to create a pipe shape at this moment. Okay, so let's copy this value and I'm gonna use a poly wire and paste the thickness value here. I can see that it's a bit too thick, so I gotta make it smaller for sure. Let's make the divisions like 10 or 12. And the normal is messed up, so let's recalculate the normal. Now let's go back to the controller. Make this smaller. Okay. Now I don't really like these part because the line is aligned. You're getting something not really symmetrical, which I don't really like it, so I might want to fix those. Other than that, I might also want to make these more smooth. This is a bit too straight, and I want to make the corner point to be a bit thicker, the center of the edges to be a bit more thinner. So in those cases I cannot just use a constant thickness value, but I need to kind of control the P scale for each point. Right, so a lot of tasks to do, but overall I do see a waving effect like that, so that's good. But let's fix all those things one by one. So first I am going to make this a bit more smoother. So to do that, let's see. Right now, the number of points for each pipe or edges is not enough. Not many enough. So first thing I could do is to increase the resolutions for each curve to have more smoothness. Okay, so I could use a final resample node, then set the length to 0.01 to have more points, and also make this as a subdivision curve to make it smoother. Alright, now after doing this, I also would like to make the thickness change based on the position. If it's close to the corner, I want to make it thicker, and if it's at the center of the edge, I want to make the thickness a bit thinner. So let's do that. And in order to do that, I need to have those information, which point belongs to in which position on the edge. I can get those information either from a primitive or an attribute, which can be outputted using this resample node with the curve view. Maybe that's what I would do. Okay, so let's do that. And I have just outputted the curve view, so I'm going to, in order to use that, I can use point wrangle. And each edge has the value from 0 to 1 from corner to corner. So if the curve view is equal to 0 or equal to 1, then that means it's on the corner. If the value is 0.5, then it's in the middle of the curve at the edge. So based on those information, I can calculate some thickness to each point, meaning set the p-scale for each point. So the scale value could be calculated using ramp parameter, and by using the curve view value. So maybe I can convert curve view to a sine wave. So sine curve view multiplied by pi, which will create a value in between 0 to 1. If the curve view is 0 or 1, then the sine value will become 0. If it's equal to 0.5, then this value become equal to 1. So you get kind of a mountain-like shape. Okay, now so it indicates that if this value is 0, you are at the corner. If the value is at 1, then it's at the center. And you can remap that value with this ramp parameter and use it as a final p-scale value. Okay, let's just go with the linear stuff and see how it looks like. So in order to use the p-scale, you could multiply it to here. And as an output, you get something like this, which is interesting, but that's not what I want. So let's remap the value here. So looking at the curve, if the x-axis of this curve is 0, then this means it's at the corner, so I want to make this larger by raising this point up. Oop, I don't want to create a new one. Just want to raise this point to 1. Okay, and instead I want to make this value smaller, so the center point will be thinner. Yeah, and you could also add additional curve if you want. It's up to you. Okay, not bad. Now I'm seeing these broken edge here. I think in order to solve this, you need to fuse the point before using the polywire. So do that. Okay, now it's being connected, but I do have some problem here. You can see that some self-intersecting is happening on the corner, so want to fix that. Now, one way to fix this is to use a smooth node, which is a bit brute force, but it does fix a little bit like that. But the problem with the smooth node is that it will also smoothen out where it is on the center. So if you don't like that, this might not be a good solution, but it still works. If you only want to smooth out the part where it's close to the center, then you could use a attribute blur with a weight attribute. You could use this weight attribute to control in which position you need to apply the smoothness. We could try that. Now in order to do that, you need to have the weight attribute. So let's go back to the this node here, or maybe before fusing it, we could apply a weight to each point. So what I want to smooth is where the point is at the corner. So we could use the similar information that I have here, that I used here, which is this sine wave, and together, maybe together with this curve. So probably just using pretty similar stuff that I have here for smooth weight value as well. So this is pretty much the same. I'm just gonna change this value to weight and create the weight attribute for each point. This. So at the corner, I want to make it really high as a weight. On the center, I don't really want to have smoothness, so maybe I can go with like something like this and make some interpolations like that. So gradually just change the weight from corner to the center. Okay. And after fusing and after polywiring, I have to make sure that those weights being transferred to the polywire. If not, then that's nothing. That's not used for at all anymore. Let's see. So I do have a weight here. I do seem to have those values being transferred. Let's also check with the color. I want to visualize the weight with some okay, so it does look like it's working. Let me change the color value to something different. Oops. Okay, so I might want to increase the range a little bit more, so I don't like this color there. Maybe after all, the infrared is a bit easier to see. Okay, so I can control the range by changing these ramp where to smoothen out. I don't know what's the best, but let's go with these. now that I have this weight, I can use the attribute blur and use the weight attribute to do the blur. So does and might need to so is it changing? Not sure why it does disappear. Okay, if I increase the value here, yeah, I can see that only the geometry at the corner is being smoothed out. So it does work, but it's being smoothing a bit too much. I might need to increase the range a little bit more for this weight. Yeah, maybe that's better. And let's try to increase the overall thickness. Okay, still have some problem here. So let's check the color as well. There's a lot of stuff going on. Well, first thing I gotta do is to make sure that if which ones works better. For this one, if the thickness is really high, seems like it's not really solving the problem. I have to increase the value really high. With this one, you do still need to increase the iterations, but yeah, it does seem to solve, but I don't want to have this kind of value here, so really have to control the weight curve here, how it should look like. Okay, well, I can see that the duration is a bit too high. Hopefully if I can fix this iterations, that will be great, but I might need to make it parameterized so that you might want to tweak this by yourself using parameters. Or maybe referring the thickness and using it as a related value to set how much iterations you need. It's a bit hard. Yeah, I guess in terms of the curve of the blurring, this is maybe all I can do here. I just need to increase the iterations to fix the corner problem. Eesh. Or adding additional smooths after this. I don't know, that doesn't sound like good solutions, but might work. Well, still has some weird edge here. Hopefully I could just do this with this one. Might be better. Oh well. And let's also make the thickness smaller on the center. That. Well, it's a bit too thin. Okay, let me raise this up a little bit and let's go to the next task. Okay, For now, let's say I'm okay with this. Now, next, kind of want to solve these part where it is being avoiding self-intersect, but it's kind of having more like an ivy-like weaving, which I don't really like because I wanted to make it more symmetrical. So to avoid that, kind of I need to avoid having these edge happening on the corner, and that happens when I create the points on a surface. Yeah. And this is due to a lack of point number, I think. When I have created the voronoi pattern, let's check it without the I see those lines here, and those lines are creating a problem for sure. So, and if I could have a point somewhere around here, then I could avoid having the center line have another cells on a center. So maybe I could add additional points to this voronoi setup to avoid those center lines. And going back to the base voronoi shape here, this is where I have moved the points which is close to the border but somewhere around here that there's not enough points which do creates the center line here or edges here. So if I could additionally add points on each border, then I could avoid having edges. So if I want to do that, then I could probably use this information together with the final point setup. So let's see. Let's move this whole set down a little bit. So let's think how I could do that. Kind of have to know the nice or distance between the points, which could be sampled from the current point layout. So let's see. First, let's decide the distance, average distance between the points by for each point. I'm going to look for the nearest point. Well, this doesn't give you anything because this will just give you the self point. So I'm gonna make it a new point. What's the parameter for this? The maximum distance I can make it really high. The total number of points that I want to find is 2, and the nearest point could be the second one. Okay, now I could get the point of this nearest point position, get the distance, Then oops. It's not correct. This has to be npt. Yeah, and let's apply this distance name as ndist to the attribute. Okay, then let's use the attribute promote to get the average of this distance value. To the detail. I don't really need to change the name, I guess. And if I look at it, okay, so the average is 0.29 and the value was, yeah, looks correct. So using this average distance value, I would like to plot a point to this boundary. Now for the initial point position, I could just give tons of points on the edge. That's fine. Or I could use a resample and using this end distance for this length here. So in order to refer to that value, I think it's safe to create a null node so that it'll be easier to refer to. I always use capital letters for the one that I want to refer to, because it's coming on the top of the list with these input parameters. Then detail ndist 0. Okay, and this will resample the curve with the specific distance. Now I could then merge the original point with this point. Let's remove the primitive. And finally use the fuse node to fuse based on the same parameter that I use to resample. And I realized it gave me a tons of points. Might want to change the attribute promote to maximum to have less point. Maybe not. Yeah, maybe not. Actually, I shouldn't use average, near distance average for a fuse, because it will just remove the original points as well. So I need to have two values. One is average or maximum, and one is the minimum. So don't delete the original, change this to min and distance, and the other one is average and distance. Okay, and for the resample I want to refer to the average, and for the fuse I want to refer to the min. Alright, now maybe I could go to the average here, make it maximum instead to have less point. Okay, rename this to maximum. refer to the maximum here. Well, still look like there is too many points here. I might add it a bit too many points here. It's a bit hard to control here. Maybe after all, the minimum could be average. Yeah, maybe this is better. I'm not sure. Let's see how it looks like then. Connecting this to here. See the final result. Well, it still has some problem. Let's see. Still has its problem. Let's see. Maybe another problem is that I'm having too many mirror numbers. So if I make it 2 or 3, then I start. I'll still have some problem here. Let's see. These are at the corners. Okay. And if I mirror it. Okay, I might having some problem with this mirror code here. Yeah, maybe this is the problem. If I look from the top view, let's increase the point size a little bit. Okay. Well, from the top view it looks fine. So maybe it's not the problem with the mirror. Well, let's look at the final result. Yeah, somewhere around here. That is caused by, so those points are not on the corner. I thought I made it to the corner, but okay. So this thing, wait a minute, this is not on the corner. And this thing, it did, wow. Okay, I realized that by using fuse it just moves the point. So that is the problem. Okay. Yeah. Sure. Yeah. Okay. So, I guess let's check. So this will change the point position with this average value. Okay. What if I change this to greater point number? Since this comes later. Yeah, that will, I think that will fix the point position to the border. Yup. And hopefully this will fix, yeah, the edge problem. There you go. And if I increase the number of weight, okay, starting to look good. And for the final view, which could be this one. Okay, looks much better. Alright. That's good. Okay. Let's hide out the edges and see what it looks like. Okay, not bad. Not bad. Now, currently the detangle thickness is a constant value, but I want to relate it with this original thickness, the final thickness. So let's do that. And probably might want to fix these corner things as well. So let's also think about that. Okay, as you can see, if I increase the thickness, there is going to be some intersections because the detangle value is constant value. So gonna have to copy this value and relate this with this value here. But if I make it too high, it's going to make too much wobbles, too much avoidance or avoid thin thicknesses, so repel. So I'm going to multiply this by 0.25 or some small numbers from the original thickness. I'm not sure what's the best value for this one. For now, I'm temporarily setting it for 0.25. And for now, it looks okay. I do see small touches here, so maybe I can still increase this a little bit. Yeah, a little bit more. Maybe somewhere around here. Okay, now the problem on the corner. Let me fix that. So, how shall I fix it? Maybe I could initially try to smoothen out using these one. Then going for the corner attribute, corner smoothness. What if I don't have it? The things that I don't like with this smooth is it just smooths constantly for every part. But it does seem to, well, I don't really want to use it. The thing, okay, let's look at the problem. The problem is that I have really high self-intersections on the corner, and that comes from setting this fuse to if I don't have it. Okay, maybe the other problem is that the thickness on the corner is a bit too thick. Going back to P scale, you might want to have a gradual change to the thickness. And I can see that the change is a bit too high. Yeah, that'll do. And I can see that it's a bit too thick. This looks good. Now, but if I do fuse, okay, so it has a less problem, so maybe I needed to refer to the original thickness here. Now, for now, but it looks a bit better. In this case, I think this works fine. And now the iteration is a bit too high, so Now this spot is really hard. In this case, normal, I mean the smooth node works better, I guess. Comparing to this one, another problem is that I'm having too much resolutions for the curve, so maybe I can reduce it. Yeah, that might do the job. Yeah, that might be the solution. So this resolution is also important, I guess, which could be again parameterized. Okay, so a bunch of post-processing parameters. One is the blur on the corner. One is these curve for the blurring, for the weight. And one is the resolutions of the final curve, final edges. But that's for the post process, so I'm not sure if I should include that in the global parameter. And if I increase this a little bit, maybe 5. Yeah. Well, as a final, as you can see, this is pretty much symmetrical, so that's what I wanted to have as a final output, and it's been weaving like these. Looking good. Now let's try checking other shapes by changing those parameters like thickness. That's too thick. Let's reduce the maximum thickness to 0.1. Well, it's up to the size of the profile, so it's not really has to be 0.1, but okay. Now let's increase the layers, or before doing that, in order to see the intersections a bit more clearly, I'm going to add some lighting effect or ambient light effect for final visualization. So ambient occlusion. This will create a mask attribute to each point. And if I visualize it as a color, this will give you a black and white or grayscale color value. Like that. It's a bit too dim, so I want to make it a bit more high contrast to see the depths a little bit more. I'm going to use a ramp parameter to create high contrast. Remapping the mask with a specific curve. Okay, so making like an S curve, you can create high contrast, or maybe curve like that. There you go. Starting to see more contrast on each curve. And I'm also going to set some material for it. I'm going to use a matte cap shader and look for some shader material, matte cap material. anything is fine, but let's see. Maybe I could use I like this kind of a ZBrush like shader, so let's look for that. ZBrush, nope. Matte. Maybe I can use this, or how do I name this? Sculpt. This one. I'll try this one. I don't think this is like copyright free, so I'm not going to include this in the final project file. So just choose your own image if you want to use a matcap shader. So let's copy this to the project directory. Where is it? Where is my Houdini file? Okay, copying it, referring to the image that I have just downloaded, and apply that material to this shape. Alright, not bad. Okay. Okay, so it's a bit more easier to see the depths. Now, let's try changing those parameters that I have. Okay, so first, number of mirrors. I might want to control okay, the the scale for the P scale for the edges, for the thickness. So let's bring that parameter to the global. New node. Where was it? Where did I set? Yeah, this one. So this ramp parameter. I'm going to call this thickness lamp. What else? Smooth weight. I don't really want to touch this, but maybe I might need to. Because this is just to fix the polygonal errors, so this shouldn't be used by the user normally. And the blurring iteration, this is the same reason this shouldn't be used by the user, but as a developer you need to have it, so let's give it. Other than that, this, what is it? This is a mask. And this is not that important, so I'm not going to give as a parameter. It's not necessary anymore. What else? What else? P scale. Yeah, this part. This could be also important. So final res. Final georet. That sounds like a dumb name for the parameter, but okay, let's make a separator to define what's important and what's not important. Okay. Something like that, and let me, okay, for the ramp parameters, I kind of don't want to show those controls here. I just want to change the curve shape, so I'm going to hide these. Okay, now increase this a little bit. Make it S-curve. Yep. Okay. Alright, well, that's good. Now if I increase the layers, should still be able to see a weaving pattern for each layers, as well as symmetries, repetitive patterns. If you decrease the voronoi repetitive numbers, you see less repetitive patterns. In this case, you're seeing this side, four side. If you increase it, you're going to see more repetitive numbers. Alright, looks interesting. And now that I look at it, maybe I do want to control this mask contrast. Yeah. Okay, let's have this as a parameter as well. Ambient light ramp. Alright. So let's also test this out with different shape. I'm gonna try with small number of layers. Start off. So this is the single layer. Small number of voronoi pattern. If I increase the point number, start to see more like a mushroom-like shape. If you increase the layers, start to see the interweaving, interlacing surface. Alright, now let's change the original profile curve here. I'm gonna give different shape by changing or redraw it, maybe. How do I delete this? Reset operation. Okay. And go to the front view. I'm gonna redraw the curve. I mean, previously I wrote it on the left side, but you could also draw on the right side, maybe. Maybe not. If I draw it on the right side, I might need to change the axis, the initial axis direction, so I'm gonna draw it on the left. Okay, let's try with these. It is a vessel. Okay, and if I look at the final result, there you go. Yep. You could use it as a flower pot or a candle holder or something. That's really look like a Diablo-like shape. Alright. Let's try changing the parameters. If I increase the voronoi repetitive number, alright. If I make it to the minimum, looks random, but there is a mirroring point. So, still looks nice. This is actually a symmetrical geometry. And if I decrease the voronoi number, interesting. If I increase the okay, starting to look like a mushroom-like shape. Yeah. Having less point number and high weaving or layer number. Yeah, so I think all the parameters seems to work fine. If I increase the thickness, wow. Oof. Now it's getting somewhere uncomfortable. This is also interesting with the really thin lines. So let me know if you have any feedback. I think I'm almost done, so let me check a comment. There are a lot of things. Thank you for the comment. So after the stream, is this video be available? Yes, this video is gonna be recorded, being kept as a archive. You can come back to the same URL to watch it freely. I am also going to upload the file that I've just created during this live stream, this exact file, to the GitHub, and I'm going to paste the URL for the project in a description page, description part of this video, so you can download it from there after the live stream. Hey. How How delighty every second geometry with v of x. Didn't got the question. How delighty every second geometry with v of x. I'm not sure what was the question about. If you could rephrase it, that would be nice. Oh. So it seems to work fine. Well, one thing that I didn't try is this wave number parameter. So let's check that out. Let's try, in order to see the effect, let's try with small number of parameters. This is fine. Okay, if I set the curve wave number to 2, it's gonna be less intersections or interweaving, logically. If I make this to a really high number, you start to have more interweaving, interlacing. Yeah, so that could be some parameters you could play with. The curve, wave, amplitude, this is also make things different. If I make it to like 0.5. Now this is also interesting, isn't it? It's not a vessel anymore. Something wicked, but interesting. Yeah. Okay. Seems to work fine. It might also be able to send it for 3D printing. That might be interesting. I didn't try that. Delete. I see. How delete every second geometry with v of x? Every second geometry, is it related to this one or not? If you, in general, if you want to delete every second geometry or every second point, you could just use modulus. Like for example, if you have a bunch of points like that, and if you want to delete every second point on this line, you could use conditions by checking the point number and calculate the modulus. This percentage will calculate the modulus, meaning calculate the remains. If you calculate the modulus with 2, that means you're getting the result of remains when you divide pt num by 2. So if you divide 1 by 2, the remain is equal to 1. If you divide 2 by 2 or 4 by 2, the remains is 0. So you get, if you calculate the modulus, the only result you get is either 0 or 1. So if you say the modulus result is equal to 0, then you're going to pick every second point, and by saying remove point, you can just delete every second point like that, if that's what you have asked. just use this one with the condition. It's not really limited to point number, but anything could be used inside the for loop or anywhere. But using this modulus calculation is the way to go to look for the every second geometry. Or if you just change this 2 to some other numbers like 3, then you are going to look for every third value and so on. Yeah. Okay, so I guess that's pretty much it. I hope you have enjoyed the live stream. I'm not sure how much it is useful for anyone, but hopefully you find it fun. Okay, that's it for today. Thank you very much for joining. I'm going to stop the live stream and go to sleep. If no questions, okay, then this is the end. As I said, I'm going to upload the files. Probably can be downloaded from the Patreon page, so the Patreon, I mean, it's free to download, so but if you could support me on Patreon, that would also be great. To continue these live stream. Next week I have things to do on the weekend, so I don't think I can do the live stream, so the next live stream is going to be on September, is it? Or next Friday night in Japan time. Okay, well, that's it. Thank you very much. Good night, everybody, and see you soon.